Hello students, welcome to this theory session of atoms and molecules. In this session, we'll be discussing about matter, about the classification of matter and the laws of chemical combination, that is the law of conservation of mass and law of constant proportion. Right? So this is our very first theory session for this topic, students, and welcome to this session. Now let's start this theory session. What is matter? You must have studied matter is anything which occupies space, right, and has mass and volume. Now that matter is also called padarth in Hindi. An Indian philosopher, Maharshi Kannad, said that if we go on dividing matter, we'll get smaller and smaller particles of matter. If we keep on dividing, we'll get the smallest particle of matter which cannot be divided anymore. Right? Let's start with the classification of matter. One is physical classification and chemical classification. That is, classification based on the physical properties. So matter is divided into three states, that is solid, liquid and gas. In solid state, the intermolecular force of attraction is what? It is very high, or the force of attraction is very strong. The particles they are tightly packed. These particles cannot flow. They exist in the form of crystals. Whereas liquid, what type of intermolecular forces of attraction is there? It is weaker than solid. And liquids, they take up the shape of container. The particles of liquids flow. In gaseous state, what type of intermolecular force of attraction is present? It is very, very weak. Right? The particles are far off from each other. The gases diffuse from one place to another. So this is the physical classification of matter. Now let's take up the chemical classification. Now matter is classified into pure substances and mixtures. Now what are pure substances? These are further classified into element and compound. Now element. An element is composed of only one kind of atoms. So the basic particle there is of only one kind. Say if I am taking iron, iron has got only one kind of atom, that is iron atoms. Sodium has only one kind of atom, that is sodium atoms. Now the element is further classified into metals, non-metals, metalloids and noble gases. Now metals, they have got specific set of properties. Like metals are good conductors of electricity, good conductors of heat. Your cables, electric cables, they are made up of metals. Metals like copper, aluminium, they are very, very good conductors of electricity. In fact, all the metals are good conductors of electricity. They exist in solid state. Mercury is the only metal which exists in liquid state. Now non-metals. Non-metals are what? They exist in gaseous state. They are the bad conductors or poor conductors of electricity. Except for graphite. Graphite is an allotrope of carbon. Carbon is a non-metal. But still, graphite is a good conductor of electricity because of its structure. We'll be studying this in the higher standards, higher grades. Metalloids. Metalloids have properties between metals and non-metals. Like silicon, like germanium, they are all metalloids. Arsenic is a metalloid. Right? Silicon is used for making semiconductors. Then is noble gases. Noble gases means noble gases are helium, neon, argon, krypton, xenon. Now why they are called as noble gases? Because they do not react with any other compound. They are stable compounds and they exist in monoatomic states. Like helium, it exists as He, that is one helium atom. This is stable. They do not react. Right? Now compound. Compound, what is compound? Two or more elements combine in a definite proportion. And they form what? They form compound. Now compound is again classified into homogeneous and heterogeneous. Homogeneous means it consists of the particles of same phase. Heterogeneous is composed of two different types of particles. The phase is different. Now mixtures. Two or more elements or compounds in any proportion. See, you cannot separate the constituents of a compound by physical methods of separation. Say if I am taking sodium hydroxide, you cannot separate sodium, oxygen and hydrogen from it just by distillation or crystallization. You can't separate it. And it has got a uniform property. It doesn't have the property of sodium, oxygen and hydrogen. It has the property of its own. Sodium hydroxide. What is the formula? NaOH. Now the sodium hydroxide doesn't have the property of, say, sodium alone, then oxygen and then hydrogen. Sodium, oxygen and hydrogen, they combine and form a new compound, that is sodium hydroxide. Now it has its own set of properties. Right? And that is altogether different from the properties of sodium, oxygen and hydrogen. Whereas if I am talking about mixture, so if I am talking about mixture of salt and water. Now that mixture has got the properties of salt and water as well. They both are not combining and forming one compound. They both are not having different set of properties. So, mixtures, two or more elements or compounds in any proportion. Homogeneous mixtures and heterogeneous mixtures. That is, mixtures can have the constituents which are in the same phase, that is liquid, 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 solid, solid, solid. Like alloy is a mixture. Steel is a mixture of iron, nickel and copper. Iron, nickel and chromium, I'm sorry for that. Steel is an alloy of iron, nickel and chromium. They are in all solid state. Heterogeneous mixture in which one of the constituent or both the constituents are in different states. So here we'll be first starting with the element. Right? Then we'll move to the atoms. Now, all matter is made up of small particles called atoms and molecules. Different kinds of atoms and molecules have different properties, due to which different kinds of matter also show different properties. It's a bit complicated sentence, but it's not that difficult. Say, I'm taking any element, say I'm taking copper. The symbol is Cu. Now this copper is made up of the smallest particle of copper. If you keep on dividing copper, so you'll get this its smallest particle, and that will be the atom. Right? So copper that completes, say I'm taking a wire of copper, or this thin strip of copper, this thin wire of copper. Now this thin wire of copper is made up of atoms. The smallest particle of this copper wire is atom. Right? Now if I'm taking the nitrogen, which is of course a gas. Now this is composed of N2. Now these are molecules. What happened? Two nitrogen atoms combined and they formed one N2 molecule. Now why is it so? See, there are certain elements which can exist independently. The atoms of the element can exist independently. They are stable. But there are elements which cannot exist independently. Say, there are elements whose atoms are unstable. Nitrogen, it can't exist independently. It combines and it forms N2 molecule. Likewise, hydrogen, it also exists as H2. So H2 is a molecule which is composed of two atoms of hydrogen. Right? Likewise, Cl2, it is a molecule of chlorine. So it is composed of two atoms of chlorine. Likewise, O2 is a molecule of oxygen composed of two atoms of oxygen. Now, if I am taking, say, gaseous as a nitrogen gas in a container or somewhere else, if I am accumulating it, now that particular gas will have some specific properties. Now, those properties will be of nitrogen atoms. Say, in our body, the basic unit of life is cell. The basic and the fundamental unit of life is what? It's cell, single cell. A cell has all the properties in it. The genetic composition of a cell decides the nature of an individual or of an individual, that's it. Likewise, atom is the basic unit of a molecule or a compound or an element. So in case of hydrogen, it has got a different set of properties. It is because of the properties of atom of hydrogen. Because of the property of atom of chlorine. So, the properties of matter depend on the properties of atoms and molecules from which it is made. Nitrogen cannot have properties of copper, or nitrogen cannot have properties of carbon. Carbon has got a different set of properties. Why? Because it is composed of carbon atoms. And carbon atoms have got different properties from nitrogen atoms. So, the property of matter depends on the property of atoms or molecules from which it is made up of, right? Now, different elements combine and they form molecules. Say, hydrogen and oxygen combine and they form water. Copper will combine with sulfur and will form copper sulfide. Copper, likewise nitrogen, will combine with hydrogen and form ammonia. Now, why is it so that they are combining in a fixed ratio? So, there are certain laws for chemical combinations. So, we have to study those laws first. That is the law of conservation of mass and law of constant proportion. Different elements combine to form different compounds. Now, this combining of atoms and molecules is governed by certain laws known as laws of chemical combination. We have to study about these laws now. There are some important laws given for the combination of atoms or molecules. So we'll first discuss about those laws. Laws of chemical combination. The important laws of chemical combination are law of conservation of mass or matter, law of constant proportion, law of multiple proportion, and one more is law of reciprocal proportion. Now we'll be discussing about law of conservation of mass and law of constant proportion in this topic. The rest two laws we'll be discussing in grade 11. So let's start with it. Law of conservation of mass. This was given by Antoine Lavoisier in 1789, and it states that during any chemical reaction, the total mass of the reactant is always equal to the mass of the product. That the mass of the reactant is equal to the mass of the product. See, if hydrogen is combining with chlorine, forming hydrochloric acid, so it should be always that the total mass of the reactants, that is here it's 2 plus, what is the mass of chlorine? Mass of chlorine here is 35.5 into 2. That is how much? 71. And what is the mass of HCl? It's 1 plus 35.5, that is 36.5. So here, what happened to the mass? It is here that the total mass of reactant is always equal to the total mass of product. Or an alternate statement of this law is that the matter is neither created nor destroyed. Matter can neither be created nor be destroyed. In course of physical and chemical reaction, although it may change from one form to another, the total mass remains conserved. That is, mass of reactants is equal to the mass of the products formed. So here what has happened? What is the total mass? It's 71 plus 2, 73. And what is it here? It's 36.5. That is, the mass of reactant should be equal to the mass of product. Where is that matter gone? This much mass of matter, where has it gone? Where has that 36.5 gram lost? Matter can neither be created nor be destroyed. Or matter is neither created nor destroyed. So it has to be balanced. It would be H2 plus Cl2 is giving 2HCl. Now the total mass of reactants is equal to the mass of products. This is simple. This is a law of conservation of mass. That is, the total mass should be conserved. In this case here, atoms of X have combined with atoms of Y, forming the compound of element X and Y. Now the total mass of these should be equal to the mass of compound. That is what is law of conservation of mass. Isn't it very simple? That the total mass is conserved. The matter can neither be created nor be destroyed. Remember this. This is a very, very important law. Let's take up this example. On heating calcium carbonate, calcium oxide and carbon dioxide are formed. This calcium carbonate is heated and we are getting calcium oxide and carbon dioxide. What is the mass of calcium carbonate? It's 100 grams. I'll be telling you how to calculate the molecular mass or mass of a molecule. Calcium oxide, it's 56 grams and carbon dioxide is 44 grams. So if we sum up, what is it? The mass of reactant is equal to the mass of product. So the most important rule is matter can neither be created nor destroyed. The mass is conserved. Total mass is conserved. Now let's take one numerical related to this. The question here is, sodium carbonate reacts with ethanoic acid to form sodium ethanoate, carbon dioxide and water. In an experiment, 5.3 gram of sodium carbonate reacted with 6 gram of ethanoic acid to form 8.2 gram of sodium ethanoate and 2.2 gram of carbon dioxide and 0.9 gram of water. Show that this data verifies the law of conservation of mass. What you have to do? It's a very simple question. It's not difficult. It is a big question, but it's very simple. You don't need to write the chemical formula, don't need to write the chemical equation. Just write the word equation from here. Sodium carbonate, I'll write the chemical formula of these compounds. Sodium carbonate, that is Na2CO3, reacts with ethanoic acid, that is CH3COOH, forming sodium ethanoate, that is CH3COONA, plus carbon dioxide and water. This equation is not balanced. I'll balance it. I'll just put a 2 over here and 2 over here. Now this will be balanced. Now what is it saying? In an experiment, 5.3 gram of sodium carbonate, so it's 5.3 gram. 6 gram of ethanoic acid. You have nothing to do with the chemical equation. Everything is given over here. It's 6 gram of ethanoic acid forms 8.2 gram of sodium ethanoate and 2.2 gram of carbon dioxide. Finally, 0.9 gram of water. So what you have to tell is that this data verifies the law of conservation of mass. What you'll do? Just add up these numbers. 5.3 plus 6. What will be the answer? It would be 11.3, I suppose. I'm not very good in maths. And this side, what will be the answer? 8.2 plus 2.2 plus 0.9. So this would be 3 and again 11.3. So these numbers, if I'm summing up, I'm getting 11.3. The sum of, or the mass of reactants is equal to the mass of products. Mass of reactants is equal to mass of products. Is this verifying the law of conservation of mass? Yes. The mass is conserved here. So this reaction is according to the law of conservation of mass. Here is one more question. Calcium carbonate decomposes on heating to form calcium oxide and carbon dioxide. Just write calcium carbonate. If you don't know the formula, write it in word form. CaCO3, it is decomposing to form CaO and carbon dioxide. When 10 gram of calcium carbonate is decomposed, that is, this calcium carbonate is 10 gram completely, then 5.6 gram of calcium oxide is formed. Calculate the mass of this carbon dioxide. Now, according to law of conservation of mass, we know that mass of reactant is equal to mass of products. Now, what is the mass of reactant over here? It's 10 grams. What is the mass of product? 5.6 gram plus we can take X as mass of carbon dioxide. Isn't it simple? 10 minus 5.6 will give the mass of carbon dioxide, and that is equal to how much? It will be 4 and this is 4.4 gram. Why so? Because according to law of conservation of mass, mass of reactant is equal to the mass of products. So this is how you can find the mass of either the product or the reactant. And there's a pattern of question which is asked from this law of conservation of mass. So this is all for the session, so students, and in the next session we'll be discussing about the law of constant proportion. I hope you have understood this session or this concept, and this law of conservation of mass is very important and it's very easy also. In the next session we'll be discussing about law of constant proportion, and then we'll be moving to Dalton's atomic theory. Because matter, when divided and divided further, you'll get the smallest, or we'll get the smallest particle, and that smallest particle is called as atom. That is explained by Dalton. So we'll be discussing about Dalton's atomic theory after that. So thank you students for listening patiently, and do have a nice time ahead.